Hello, good morning. Good morning to our Ahmed, Saleh, Tarık. Okay, hello. Thank you for your attendance. Today we will continue with the brushless DC motor. Firstly, I will show some design example. I will upload these papers. Now, your homework, your
Good
midterm
morning,
project
Hujam.
actually. Good morning, good morning.
Can
Also,
I
I
ask
ex
you a small question about
yes,
midterm?
yes.
When's the deadline of the midterm?
Normally next week, but I will extend one more week for your midterm project. Also, you have a 2 weeks after today. You have a
Uh-huh.
2 weeks. Uh-huh.
But- Okay.
Actually, one of New Year, starting of New Year is the deadline. And after New Year, you can send me.
Uh-huh. Okay. Thank you,
O-
Hujam.
Okay. Also, I will upload your final project. Your final project will be related with the midterm project, actually. If you complete the midterm project as a goodly, you can finish final project, actually. Don't worry about it. Midterm project is important. And then you will add some definitions, some blocks, your midterm project. You will obtain final project. Okay. Now,
Hujam,
uh,
the final project is the same file you uploaded from first semester?
Nearly. Actually, no. Normally, your midterm project simple electric vehicle design. Actually, I will explain some hints today.
I th-
Final.
I I talk about
Yes.
the final project. You upload some 4 or 5 files about final project when the
Mm,
semester start. It's the
ah,
same
no. Same. It's just an example. It's just the
example.
last year final
Uh-huh.
project.
So there are new project, different
Yes,
project.
yes. There are new project. Actually, I will. I think I will give like an example project now. Uh, midterm. Actually, I will give you um, normally I will give you final project electric vehicle design, but in final project I will give you electronic differential system. I will explain it. Don't worry about it. It will be different. Don't worry. First, please focus your midterm project. Okay,
Okay,
midterm
thank
project
you.
first. 2 weeks. You
Hocam
have
ben
a two
midterm
weeks.
projesini göremiyorum ama
Neyi göremiyorsun Ahmet?
midterm projesini yüklediniz sanırım da göremiyorum ben onu.
Kontrol edeyim. Kontrol edeyim Ahmet. Yükledim. Kontrol
Hangi
edeyim dur.
dosya ismiyle yüklediniz hocam?
PDF olarak midterm projesinin altında bir bakarım Ahmet. Tamam, aklımdasın. Bir
Tamam.
hafta uzattık, dert etme.
Tamam.
Tamam. Okay, now we can start with the good paper. This paper is like your midterm project, typical electric vehicle design project. Okay, what's the hint? Normally, in final project, you can start with some definition, some literature survey. Okay, this is your introduction. And then we will continue with the materials and methods. I am waiting from you in midterm project. You can see top of the bottom of the paper. You can see. I will explain again. You will define and drive cycle. Okay. And then drive model, electric motor model, transmission model, vehicle model, and battery. Now, we will continue. What is the drive cycle? In electric drive system, we need a speed reference. For example, if it is electric vehicle, you will use like this one. This is NEDC. In your midterm project, you can use NEDC. NEDC is meaning that new European drive cycle. A motor company generally, for example, vehicle company Volkswagen. Volkswagen use this velocity curve in their vehicle test procedure. Okay, this is typical city traffic speed curve. Another one UDDS. UDDS, uh, another type uh, drive cycle model. Also, we have lots of drive cycle. For example, FTP 72, also Japanese cycle, also worldwide harmonized light duty cycle WLTP. Nearly maybe 20 drive cycle are available in the world. In your simulation, you will define n drive cycle. You can use NEDC. We have a good point here. MATLAB library has NEDC drive cycle. Okay, you cannot create it. You can only upload it. Drive cycle is like this one. And then we can continue. This is driver model. Bakın, don't forget it. This is your midterm project. In your homework, you will design as a simply drive model and electric motor. Now, if you completed your homework, you can finish this one. Okay. Also, I explained the drive cycle. Okay. Now, vehicle model and transmission model. Now, driver model. Okay. Actually, you define it. Driver model. In your homework project, you create NDC motor. You create like this one electrical machine simple model. You will use it. Okay, same in yani your homework project is very benefit in your midterm project. Now brake model. We cannot use brake model. In final project, maybe I will give as a bonus why brake is important for us. You know we cannot say electric motor. Electric it is meaning that electric machine. Why we can say machine? Because our motor as a working sometimes generator. This is called as a regenerative braking. Okay. Yani sometimes motor, sometimes generator in my vehicle. This is called as a regenerative braking operation. In the deceleration time, your motor recover accelerated energy. This is called as a energy recovery. It's uh, very important issue for electric drive and electric vehicle. In the internal combustion engine, we have no like such a this option. We have only this option, only electric vehicle, regenerative braking. But in your midterm project, I am not waiting from you brake model. If you want, you can add it. It's very good actually. Electric motor model, you can you complete it actually in your midterm project, homework. Now, transmission model. What's the transmission? Transmission is very easy. Why? You calculate your motor torque, you calculate your motor power and motor speed. What's transmission? Transmission is gear ratio. It's just a number. Don't forget it. For example, your vehicle goes to 180 kilometer hour. Also, you need at this situation 200 Newton meter. However, your motor is different speed and different Newton meter. You will add gear. Gear is meaning that only multiply number. For example, 4. Your motor generate 100 Newton meter. You will multiply it using only number. For example, 4. 100 Newton meter times 4. In your vehicle wheel, you will obtain 400 Newton meter. This is transmission. Okay. Maybe you can add transmission efficiency like this one. And then we are continuing battery. You will create a battery model. For example, you can use this equation. This is called as a Coulomb counting. What's the Coulomb counting? you will define a capacity for your battery, for example, 25 kilowatt hour. And then you will see in your motor output a current level, current consumption. Current consumption, time, motor armature voltage equal watt, you know, also watt times hour, watt hour, it's energy. You defined the battery, you remember, 25 kilowatt hour. Battery level minus motor consumption power. This is called as a Coulomb counting. It's very easy method. Okay. For example, your motor works 1 ampere. Your armature voltage 100 volt. 100 volt times 1 ampere. 100 watt second. You will convert it watt hour. If you use minus equation, I say again, battery capacity minus motor consumption, it will be give you battery level state of charge. And then global model, EV global model. This is important actually, but it is not complicated. Longitudinal dynamics. I explained the 3 or 4 weeks, I don't remember. Firstly, in first step in midterm project, you will define torque demand, power demand. Okay. First one, aerodynamic force. You will see this equation. Frontal area, drag coefficient, etc. Ahmet, sesim geliyor mu benim? Yok.
Geliyor hocam şimdi. Şu an ama üstünüz... Ha, şu an geldi galiba.
İnternet gitti arkadaşlar. My internet is breakout. Now it's come. Okay, so the first time internet is breaked. Okay, we will continue with the global model. I said to you this is your first equation, and then second equation. Also define third equation, FRP. After that, you will calculate total force demand using this equation. It will give you your total force demand. Okay, total force, don't forget it. It is not a torque, force. And then you will calculate Newton meter. After the calculating of total force, you will obtain how much torque is needed for your electric vehicle. What's the methodology of it? It is depend on your wheel radius. This is your total total force demand, and then we are waiting from you torque value. Torque value is equal radius time force Newton meter. It is unit force Newton meter. Where does it come from? Wheel radius. Okay. Now we have this parameter. For example, some students say me, I am not finding the vehicle value. If you read the paper, for example, this is your Ford Focus electric, very old model values. You can use this one. Vehicle mass 1700 kilogram. Vehicle front area 2.42 meter square. Wheel radius is clear. Transmission ratio, this is the gear ratio, 7.82. Drag coefficient, rolling resistance, yes. After the calculation of vehicle torque demand using this parameter, it's critical issue. Motor parameters. Rolling maximum torque electric motor. Their motor 250 Newton meter. Maximum power electric motor 107 kilowatt. Loss constant, work loss constant, inertial loss constant, it's not important for us now. Another critical issue, battery capacity. You can select like this one, but using a reference, 23 kilowatt hour. Their voltage is important for you, 350 volt. Internal resistance, maybe it's important. If you design your own battery, it's important. Also initial state of charge. Good. Yes, this is the result. In your midterm project, we are waiting like this result. State of charge variation. Ending of your driving cycle, you will complete a trip using your simulated vehicle. This is energy consumption state of charge. In first starting moment, their battery 81%. End of the cycle, it goes 75%. I'm waiting from you like this one. Okay. And then a voltage variation. Maybe it's important, maybe no. It's your decision. But the battery current variation, it's meaning that battery or your motor current, actually they are nearly same. I am waiting as a second issue, current variation in your midterm project. Okay, why sometimes It has a peak because this is the in driving cycle acceleration time, acceleration time, acceleration time. What's meaning of that? This is regenerative braking time. Current goes minus. At this situation, they generate energy. Also, second one, third one, velocity. You will show me your vehicle velocity variation. Actually, it depends on your driver cycle. Yes, but you have a PI controller. You have a reference. You have a feedback. You will show in your midterm project reference speed value and measured speed value comparison. Next one, battery power variation. It's meaning that motor power variation. You will show as a fourthly. Last one, distance. You will give a table in your midterm project. Distance, actually it is clear because distance is dependent on your drive cycle and EDC. It is, I suppose, that 11.35 kilometer, I suppose that. Also state of charge at the end of the cycle like this one. Energy consumed. Power loss is not important. Transmission power loss is not important. Battery power loss is not important. I am waiting from you in your midterm project these three parameters as a table. Minimum four figure, yeah, for result, and one more table like this one. Also, maybe you can compare with the different EV model. For example, you can compare it with this paper. I will upload it. Also, state of charge, etc. Okay. Now we will continue with the brushless DC again. Last week we start the brushless DC motor. Today we will continue with the simple homework definition. Okay. Now, last week I tried to explain the brushless DC motor. Today we will continue again. Firstly, maybe we will give some brief about last week. What's the brushless DC motor? You know, BLDC are the one of the motor types very popular. In drone, in lots of simple application, etc. Automotive, maybe aerospace, consumer electronic, medical, industrial automation and instrumentation, etc. Okay. However, we have one critical point in the brushless DC motor. As the name implies, BLDC motors don't use brush, okay, for commutation. Anymore, I know, but it's just a brief for last week. Instead of brush, they are electronically commutated. BLDC motor also have many advantages. I say some few of them. Better speed versus torque characteristic, high dynamic response, high efficiency, also long operating life. Maybe most important one, noiseless operation. Also, you can reach higher speed range using BLDC. BLDC motors are a type of synchronous motor actually. It's called as an AC motor. In the name of the BLDC, maybe you can say this is DC motor. No, this is type of synchronous motor. This means that magnetic field generated by the stator and the magnetic field generated by the rotor rotate at the same frequency in synchronous motor. BLDC motor don't experience the sleep. What is the sleep? In the asynchronous motor, we have two type, synchronous motor, asynchronous motor. Why we can call it synchronous? Why we can call it asynchronous? In your motor conversion course, maybe you can remember. Asynchronous motors has a sleep, magnetic rotating field speed, and the mechanical rotating speed are not same. This is called as a asynchronous or induction, you remember. This is caused from sleep. In the BLDC or synchronous machine, we have no sleep. In brushless DC motor, so we can say magnetic field frequency and the mechanical speed frequency are same. BLDC motors come in single phase, two phase, and three phase configuration. Corresponding to its type, the stator has the same number of windings. Out of these, three-phase brushless DC motors are very most popular and widely used. Okay, now we can say something about the stator. The stator of a BLDC motor consists of stack steel lamination. Maybe I will show you in next slide. Yes. This is your motor stator. You can see in your screen. This is brushless motor stator. Don't forget it. It's not a rotor, only stator. The stator of a BLDC motor, stack steel. What's the stack steel lamination? You can see here steel. These are stacked steel, but it's called as a laminated. Okay. Windings placed in the slots that are axially cut along the inner periphery. Where is it? This is your winding. This is your slot. You can track my arrow. This slot, slot, slot. You can winding here. You can see. Traditionally, the stator resembles that of an induction motor actually. However, the windings are distributed in a different manner. Most BLDC motors have three stator winding connected in a star fashion. What's the star fashion? Motors are connected as a star or delta. Okay. If all phases are connected as a single point, this is called as a star or Y. Okay. Delta, it's meaning that you can remember from uh, conversion course. Different winding type. Only difference with the stator and the stator winding type. For example, if you use Y, generally we can use Y, but the main reason for delta connection in the BLDC, if you want to reach high speed, you can use delta connection. It's regulate the current level of the motor actually. Also, there are two types of the stator winding variants. One of them trapezoidal, you can see, one of them sinusoidal. This differentiation is made on the basis of interconnection of coils. Connection type of your motor, it will give you motor type, back EMF type. If your back EMF is like this one, trapezoidal, this is called as a brushless DC machine or trapezoidal motor. If your back EMF waveform is sinusoidal like this one, this is called as a sinusoidal back EMF. These are very important. As their names indicate, the trapezoidal motor gives A back EMF as a trapezoidal. Yes. Sinusoidal motor. Sinusoidal. Yes. One more thing. There are not one, two more. In addition to back EMF, the phase current also has trapezoidal and sinusoidal variation. This makes the torque output by sinusoidal motor smoother than that of the trapezoidal motor. Main things, torque output. If your motor is sinusoidal winding and sinusoidal back EMF, your torque output will be smooth. So, at this situation, we can say permanent magnet synchronous machine has smoother torque output rather than brushless DC motor. Okay. However, brushless DC machine construction is very easy. Their winding is called as a very easy manufacture calling type. It's calling it very easy. For example, the last week in laboratory we are using the concentric winding techniques with 5 hours, for example. For example, we can made it in surf PMSM motor servo motor model. Probably it will be very hard. It's called as a concentric winding. BLDC motor generally use concentric winding. If you see a BLDC motor in your lots of time you will see BLDC motor in your life. Their winding it very easy. You can check it. For example, in our laboratory, maybe you can come. You will see some BLDC motor. Their winding very easy, but you will see servo motor. Their winding is very hard. It's interesting. Now, another thing, rotor. This is your rotor. The rotor is made of permanent magnet, and can vary from 2, 8, maybe high pole number. What's the pole number? These are. Maybe another thing, this is the surface mounted. You can see this is your magnet. This is called as a surface mounted. Also, what's the pole number? 4 pole, 2 pole pair. Okay, 4 pole, 2 pole pair. This is interior permanent magnet. Okay, surface mount, interior. How many pole? 6 pole, 3 pole pair. This is interior permanent magnet, another type of interior. Generally, we are called it the rectangular magnet. Maybe we can say this is embedded. This is embedded. This is inserted. Yeah, same as actually we can say interior magnet. If you want to divide two of them, this is embedded. This is inserted. Which type of permanent magnets are available in the market? One of them, neodymium. Another one, samarium cobalt. It's interesting, samarium cobalt. And also neodymium ferrite boron. Generally, we are using neodymium ferrite boron. This is called as a rare earth alloy magnets. Also, lots of researchers focus the neglect them because they're actually they are like a gold, like a silver. It's very hard to find it. Generally, China generated. China has some neodymium mine. So lots of company, for example, Tesla, Focus, minimum neodymium magnet type motor. It's another interesting issue. Evet. Another part, Hall sensor. What's Hall sensors? Unlike a brushed DC motor, the commutation of BLDC motor is controlled electronically. To rotate the BLDC motor, the stator windings should be energized in a sequence. We have three phase, you know. We need a sequence. This sequence is depend on your motor position. What's the rotor position? Rotor position is sensed using Hall effect sensors. What's it? Whenever the rotor magnetic poles pass near the Hall sensors, they give a high or low signal indicating the N or S pole is passing near the sensors. It's interesting. Your rotor, this is, or this is rotating. Your Hall sensors give a signal closing the magnet as a periodically high or low signals. It detects the magnet, it will send high. If it send a zero, there is no magnet at this position. After that, you can estimate rotor position as a very easily because you have uh, only six commutation step. Yani one high, one low, one high, one low, one high, one low. Only six probability. Also, generally, which type of sensor? For example, after the course, you can write all sensor types. I suppose that the very cheap one, 505, I suppose that if I don't remember as wrongly, 505 is the most popular Hall sensor. You can check the working principle of Hall sensors. Maybe we can say some torque speed characteristic of BLDC. This figure is very important for us. If you control a drone, if you control a industrial machine, etc., this curve is very important for us. For example, in your midterm project, it's very important. This figure shows an example for us, torque speed characteristic. There are two parameters used to define a BLDC motor. One of them peak torque, one of them rated torque. Okay. During continuous operations, the motor can be loaded up to rated torque. In a BLDC motor, the torque remains constant for a speed range up to rated speed. The motor can be run up to the maximum speed, which can be up to 150% of the rated speed, but the torque starts dropping. Normally, this curve like this one, actually torque is constant and then drop. This is constant torque region, this is constant power region. Applications, for example EV, that have frequent starts and stops, uh, reversals of rotation with load on the motor demand more torque than the rated torque. This requirement comes for a brief period, especially when motor starts from a standstill. For example, in your electric vehicle, acceleration time, you need peak torque, but its time is very, very short. Okay, if you select your motor for acceleration time, you need very high demand torque. This is wrong. This is just a very short time. In motor catalog, for example, I will show you one catalog. Wait me. This is TM4 motif motor. I will open it. Very popular electric vehicle motor. Yes, this is very popular. Integrated motor and inverter. Lots of company use this motor in their electric vehicle. TM4. This is brushless or permanent magnet synchron machine. Same. What's the things? Peak power. Actually, its peak power 150 kilowatt. Okay. However, its continuous power only 70 kilowatt. Okay. This is peak power. Also, its peak power 360 Newton meter. However, it is rated torque 120 or 30, I suppose, that Newton meter. Okay. This is maximum operating speed. It's not a nominal speed. It is not a rated speed. Maximum operating speed. In second page, what's the system features? Three-phase permanent magnet motor, like a brushless. High specific gauge, low electromagnetic noise, yes. Low cogging and ripple torque, thermal protection. Their voltage 450 DC link. Maybe you can use this value in your midterm project. It's your choice. Cooling type, water glycol. Also IP69. Also inlet temperature 65 centigrade degree. Yes, this is important. Bakın, peak power 120 kilowatt, continuous power 70 kilowatt, peak torque 275 newton meter, continuous torque 120 newton meter, maximum operating speed. Don't forget, continuous power and peak power are different things. Okay, don't forget it. For example, if you want to select a motor for your electric vehicle or another application, for example, elevator, acceleration and deceleration time is just a very short time. Don't forget it. Now, we return another slide. Yes. Okay. For example, my best efficiency point is here, rated speed and rated torque. This is my high efficient working point. In this point, my efficiency will be low. In this point, my efficiency will be low. This is rated point. At the rated torque, at the rated speed, we are focusing rated value. This rated value is meaning that high efficiency working point. Okay. Next week we can continue. Next week we will continue with the whole sensor back EMF and waveform. Also, how we can select suitable motor for our application, etc. Next we will focus these topics. Thank you for your attendance in this week. Good luck in your midterm project. See you in next week. Okay. See you, dear all. Bye bye. Söyle Ahmet.
Hocam şu dosyayı yükleyeceksiniz ya, onu midterm adıyla direkt yükleyebilir misiniz şeyde?
Tamam.
Bir şey olsun, oradan ben daha rahat görünür en azından. Tamam. Tamam hocam.
Tamam. Görüşürüz. Sağ ol. Hoşça kal.
Görüşürüz.
Bye bye.